short story about this topic. A certain man called me and said, Prof, I've read, I've seen this title, The Romance, and he told his wife that this Inaugural Lecture, you are going to follow me, so that when the time comes for romance, I'll see someone to romance. And I didn't stop there. He said, oh, there are three components: mathematics, statistics, and data. He said he knows mathematics too well. He can solve maths. He said, Prof, can I come with a piece of paper and bio today? I said, yes, you can come. He said, statistics is easy, but data, I will provide data. I said, what do you mean? I said, I have MTN network. That you are going to provide data. And I said, sir, relax, Prof. Which network do you use? I said, Airtel. I said, I'm going to provide data for you. Can you imagine that? Okay, thank you so much. This inaugural lecture is the second from the Department of Statistics and the third for the subject area of statistics. I will not waste too much time in talking about the mathematics, but I will try as much as I can to preserve the beauty of statistics and data. The inaugural lecture is dedicated to Almighty God and to my lovely family. Mr. Vice Chancellor, sir, this is the outline for this presentation. We are going to look at the preamble, introduction. We look at my contribution to knowledge in the development of statistical methods for data analysis. We have the session 3 talks about statistics of inaugural lectures in University of Benin. Recommendations, conclusion, acknowledgement. Mr. Vice Chancellor, sir, from the onset, we have that mathematics, statistics, and your own food, of course, they are part of God's creation. If you study the book of Genesis from chapter 1, from verse 1, get to the last chapter, that is verse 31, and part of chapter 2, you will see that the account of creation concerning mathematics, statistics, and data are well spelled out. And we have the statistics of things created, we have the mathematics in the creation, and we also have the record of things created, which is data. Okay? So the statistics of things created, then we have the heaven, we have the earth, then we have the morning, evening, water, dry land, we have grasses, animals, and all kinds of animals, their names as well. That's what we have as statistics. We have mathematics in the days of creation. We know that the first day, the creation started, and creation continued. The second day, third day, fourth day, fifth day, and sixth day. On the seventh day, God rested. Of course, we have 1, 2, 3, 4, 5, 6, 7. Then these are counting numbers. You see that the days of creation are ordered. They're ordered in sequence. And it has a mathematical principles, which is what? Arithmetic progression. And the creation starts 1, 2, God never jumped a day. I have 1, 2, 3, 4, 5, 6, 7. Someone asks, Prof, do you mean, is that how we got a week? Because 7 days make up a week. Okay? Now, I want to ask, maybe you go home and find out. The first day that creation started, what did God create? The first day, is it on Monday? Is it on Tuesday? Is it on Wednesday? I don't know. Please, when you get home, you find out. But I know that on the 7th day, that God rested. We have what is Sunday, some say it's Sunday, some say it's Saturday, and some that belong to, we say Wednesday. Please, I'm going to give you assignment today. Find out the first day that creation started. Is it on Monday? Find out. The day God rested, is it on Sunday? Is it on Friday? Is it on Wednesday? So, what the man asked me, whether to come with biro and paper, please, when you go home, go and get the statistics, solve the mathematics, and let us have the answer. Thank you. Then we have the record of things created. The record of things created are put in numerical form, which is quantitative data, and also in non-numerical form, which is what qualitative data. We have a nominal and we also have an ordinal. Okay, so you now see that we have mathematics, statistics, and data in one fold. I'll be able to explain that. Then we move on. You look at this beautiful picture we have. We say triple romance. Okay, you see statistics hanging on the left hand over mathematics and the other one on the data. Okay, then you now see that statistics is the principal actor here, because you know statistics needs mathematics and also it needs statistics. Of course, statistics is at the center of this romance. When I say that statistics is the groom, somebody will say, Professor, you are right. Or the mathematics and data are the bride. Okay? So if that is the case, that means the statistics has two wives. Don't laugh here. I'm not a fan of polygamy. No, I have my two wives is here. So, and I'm not ready to marry another wife. So statistics. so on a later move, this is not to advocate for polygamy. The romance here walks the talk. The romance here walks the talk in the development of statistical methods for data analysis and interpretation. Thank you. The statistics, as I said before, the left hand is hanging on mathematics. The right hand is hanging on data. Okay? Statistics here needs mathematics. It's not that, it's not. It needs mathematical tools. Mathematical tools from statistics to develop statistical methods. And statistics needs data to validate the statistical methods. Okay? So that means these three, you know, initially I said they are in one fold. You see that statistics needs mathematics, statistics needs data, and the three of them must romance for you to have statistical method. Now we have introduction. You know, we have three key words in this title. We have mathematics, we have statistics, we have data. So I'm going to explain mathematics, I'm going to explain statistics, I'm going to explain data. I'm going to tell you the departure point of statistics from mathematics. Okay? Then we now see that mathematics is a field of study that discovers mathematical methods. These are the components of statistics. Mathematical methods, theories, and theorems. These are three that mathematics developed and proved for the needs of empirical sciences, such as statistics, insurance, such as engineering, and others. Okay? Now, statistical modeling, statistical theories, statistical theorems, and frameworks are developed from mathematical tools derived from some mathematical courses like functional analysis, like complex analysis, Lebesgue major theory, reanalysis, linear algebra. These are mathematical courses that statistics will borrow tools from to develop statistical methods for data analysis and interpretation. Okay? Then statistics involves numbers. Yes, when you talk about mathematics, you are talking about numbers. Okay? It involves shapes, it involves patterns, and it involves mathematical methods. Okay? Then we also say that you can also develop probability theory and probability distributions for major theory, algebra, functional analysis. You can also develop experimental design from combinatorial analysis and linear algebra and matrix algebra. Then we have statistics. Statistics is a science of data, mathematical based and domain neutral. It involves collecting, analyzing, interpreting, and presenting data for inferences. It is a multidisciplinary subject that cuts across all disciplines, such as medicine, such as finance. Okay, we have statistics in medicine, which is medical statistics. We have statistics in finance, which is financial statistics. We have statistics in biology, which is biometry or biostatistics. In fact, statistics is everywhere. In a mathematical sense, we say that statistics is everywhere dense. Everyone needs statistics. Even the market woman at Lubini practices statistics unconsciously or consciously. In fact, there's no field that you won't talk about statistics. Those in medicine, when you talk about clinical analysis or clinical trials, they are talking about statistics. You need statistics to do your data analysis. Okay? So, and there's no technology in this 21st century that don't have statistical component or statistics component. For example, there's no phone without statistics, no web serving without statistics, no biometric recognition without statistics. Of course, there's no law firm without statistics. In fact, mathematics you cannot do without statistics. Statistics everywhere. In engineering you have statistics. Statistics everywhere. Thank you so much. Then we have statistics provides a basis for good decision making, planning, prediction, proper management, monitoring, and evaluation of policy frameworks. Mr. Vice Chancellor, sir, you need statistics components. Statistics of IGL of the university. You need it. If you yes, that will help you to drive your vision. So you need statistics of the IGL components for you to drive your vision. So you need statistics. Thank you, sir. Allow me to have this quote. This quote, it said, "It is the mark of a truly intelligent person to be moved by statistics. If you're not intelligent, you cannot be moved by statistics. It's only intelligent people that statistics can move." So, and I know you have intelligent people here. So statistics will move you today. Then I want to draw a distinction between mathematics and statistics, because some of you will say statistics is mathematics, but it's also mathematician sees numbers the way the numbers are, but statistician sees numbers as data. And once a statistician sees number as data, what comes to his mind is data analysis. Okay? And what comes is statistical method. And what comes is you interpret or you draw inference and interpret and make decision. Okay? For example, we have a result of a student in 5 courses. You have 50, 60, and 80. Okay? Now, to a mathematician, is interested in the number, and you also find the average. I will tell you that the average score is 58. Don't tell me whether I've done the calculation. You can do that. But I know I'm right. So 58. But to a statistician, that scores are data. Okay? What will draw statistician's attention is the mark 80. 80. So statistician will circle that 80 because it is an outlier. Okay? And if you take out the 80, mean is not the average score. Okay? That means statistician failed it. The mean is 50, which is the median. So when you have outlier, okay, we'll call it extreme value, okay, it draws attention. If I'm to look at those scores, I will further ask more questions. Who taught that course? Because if you look at the scores, they have 50, 50, 50, 60. All of a sudden, you have 80. I will find out who taught the course. I will also ask for the score sheet so that I can look at the scores of other students. You see, statistics is making more, asking more questions, okay? To drive at conclusion, but mathematician will just give you the mean. I think most of time, maybe during my validatory lecture, we have more to talk. So data is a process information, okay? It's a process information, and we have different sources of data. We have agricultural data, we have meteorological data, we have census data, medical data, estimated data, and so on and so forth. And you can collect your data through measurements, through surveys, through polls, through questionnaires, interviews, and the rest. And you can also analyze your data using statistical methods. And also, you can use post-analysis methods like Tukey test. We have Schaeffer's method, and so on and so forth. Okay? Mr. Vice Chancellor, sir, I want to say this. I say, do not manipulate your data to project your desire. Do not manipulate your data to project your desire. It's unethical for one not to allow data speak. So you must allow data speak for you to get the real facts. My contribution to knowledge in the development of statistical methods for data analysis. Mr. Vice Chancellor, sir, my research focus has been in the development of statistical methods for handling data analysis in the following areas of statistics. We have regression analysis, we have experimental designs, we have response surface methodology, and we have statistical distributions. We have regression analysis. What we have here is a linear regression connecting dependent variable and independent variable. If you watch, you see what I'm pointing at is the parameters of linear model. In fact, when you have a car has 4 tires. If you take out the 4 tires, the car cannot move, cannot fly. So parameters of linear model is like tires of car. So for you to use your linear model, you must find the parameters. If you can't get the parameters, the linear model cannot fly. You can't use this for prediction. So the first task is to determine the parameters, okay? And you have different ways to do that. The first talks about using least square estimation method. So when you use this method to obtain your estimates, that is the parameters of the linear model, you are actually having least square estimator. And when we have outliers, SU values in the data set, this linear square estimator fails. It's no longer robust. Then that's led to introduction of least absolute deviation. And we, Bebu and Ogundele, now investigated the robustness and the efficiency of least absolute deviation, and we now discover that least absolute deviation estimator fails to give robust estimates of the regression parameters when there are outliers in x-axis. Then Ogundele and Bebu 2018 developed a double-trimmed estimator with data dependent cutoff points approach that's robust to outliers in both x and y axes. So we decided to also compare this double-trimmed estimator with least square estimator and least absolute deviation estimator. Using all this, we have equation 3, 4, 5. 3 talks about the parameter estimate, 4 talks about robustness, and the 5 talks about the efficiency. Then we now compare these 3 estimators. The first is when we don't have outliers in the data set. The least square estimator appears to be best and perform better unbiased estimator. Then when data set is contaminated with 40% outliers in y-axis, we observe that the least square estimator is biased and not efficient. We have the least absolute deviation estimator and our double trim estimator are robust to outliers. Then let me use the DTE, that's short form of a double trim estimator, is more robust than the least absolute deviation estimator. Then when we also have liars in x-axis, the least square estimator and the least absolute deviation estimator are biased and not efficient, but the one developed by Gubelen and Mbewu 2018 is efficient and robust to outliers. Then, of course, when we have data sets on both axes, then DTE is recommended and is the best. Then we talk about when we have when the independent variables in multivariate linear model are corrected, whereas when they are dependent, then we now talk about the rich regression model with rich parameter k. Then we have different researchers have developed statistical methods to determine this estimator k using eigenvalues of the column matrix of the regression model, but they did not consider when the eigenvalues we will have outliers in the eigenvalues. They did not consider that, but they made use of the median of the eigenvalues, and also they used the mean. But we now discovered that when there are outliers in the eigenvalues, then their methods will not work. Then we now decided to introduce the geometric mean, and also we use the median of the eigenvalue, and we were able to develop a statistical method given in equation 6 for finding the ridge parameter. And the proposed estimator is proved to be robust to outliers and skewness of eigenvalues of the matrix. It is a better estimator than others. Then this is another area of my research focus, experimental designs. So experimental design is a technique that helps an investigator to plan and conduct an experiment, analyze the data generated, make inference and conclusion, reference the objectives of the experiment, Wu and Hamada 2000. Then we have the researchers that have developed the theoretical framework of the experimental design, and the first experimental design that was developed is called complete randomized design, CRD. Then the CRD structure is defined in equation 7. The left-hand side talks about the response, and the right-hand side, you have the mean, grand mean, you have the treatment effect, you have the block effect, and you have the error term, which is normally distributed with constant variance and zero mean. Then Ojukwu and Mbewu and Ojukwu 2006 developed an application software that overcomes the mathematical complexity involved in analysis of CRD. Of course, we decided to compare this result with system software such as STARS and JSTAT, and of course, the same results were obtained. Then we have Ewupe and Mbewu 2011 advanced the choice of CRD, that complete randomized design, with emphasis on the D-optimality criterion. Then the resulting D-optimal CRD is the design with minimum determinant of inverse of the information matrix. This method or this design is useful when you want to choose between 2 or 3 or 4 designs, the best design that gives the optimal result. Then you can use this method. Mr. Venture Officer, this is another area of my research focus, that is response surface methodology, RSM. So RSM is a collection of mathematical and statistical techniques applied in the modeling analysis of data, in which response is influenced by one or more explanatory variables. We have Box and Waste in 1951. Of course, the RSM has three stages. We have the first stage is the experimental design stage, the second is the modeling stage, and the third stage is the optimization stage. I'm interested in modeling stage. So here my interest is on the modeling phase of RSM. We know that ordinary linear regression and local linear regression models are used for modeling RSM data, but they perform poorly for small sample size and sparse data, which is typical of RSM method. Okay, to address this problem, Equasa and Inaugural 2022 introduced a locally adaptive bandwidth selector in the local linear regression to capture the RSM data specification. And this method is applied within the local linear regression model to fit stimulated data and mixed fish quality data. Our results in terms of goodness of fit and optimal solution demonstrate that the local linear regression model with the locally adaptive bandwidth selector performs better than ordinary linear regression and local linear regression models proposed by Ijinwe and Ibewu 2014 and 2016 for modeling RSM data. In search of more robust non-parametric regression model, Equasa and Ibewu also 2022 also developed an adaptive averaging regression model for RSM data. Here we made use of the two regression models. We use the method of convexity, that is the convex combination of two linear regression models. One is kernel regression model, the other one is local linear regression. So we combine the two. In mathematics, we say it's a hybrid. It's a hybrid method because you are connecting two regression models together through a convex combination of the regressions. Then we have the statistical method given in equation 9. Okay, then we applied this statistical method in single and multi-response problems, and we observed that this method is novel because it's well cited in the literature. Then this AVGR model, leveraging on locally adaptive bandwidth for 50 procedures, does better than other linear regression. Of course, this is a non-parametric regression model. Then Ibewu et al. 2020 studied the minimization of the surface roughness of middle steel material using a modified model robust regression tool. This research work was sponsored by TED Fund. The research results are useful in machining processes and metal cutting in engineering industries and factories. Mr. Vice Chancellor, sir, I also worked on statistical distributions. If you look at the picture here, these are the shapes of statistical distributions you can come across. We have the normal distribution where the mean, median, and mode are equal. Of course, when you live a normal life, you know, your life follows normal distribution. You don't have problem, okay? But when you don't live a normal life, wahala everywhere. You go like this, you go like this. You talk about the skill. You have the skill distribution. The other type, your life, no, not your life, the life of enemy. Life of enemy follows skewed distribution. You can have negative skewed, it can also be positively skewed, okay? Then we have a multi-modal distribution where you have more than two modes. The peak gives you the mode, okay? So these are the different types, shapes of distribution you can come across. Okay. Then Ibewu and Obianedi 2010 modeled failure times of Karman machine using log normal and gamma distributions. Data on the failure times of Kama machine were collected from a steel company at Warri for 3 years. The results obtained from the data analysis show that gamma distribution is preferred in modeling failure times of machine. These distributions I mentioned are classical distributions. When you have outliers, or when you have outliers, or you have a heavy tail distribution, or you have skewed data sets, then it becomes complex. Then you now begin to look at distribution that is more flexible and also chartable. Then because of that, researchers now began to improve on the classical distributions. Okay. Then in line with the research trend, Mbegu and eBay 2024 introduced a novel distribution called the Weibo generalized inverse exponential log logistic distribution, given in equation 10. In fact, that expression or that equation took my PhD students weeks, months, 2 years to derive that equation 10. And this work is published in one of the topmost statistical journals. It's a very novel. So to look at what you have observed in that equation 10 can be translated into that picture, this picture you are seeing. Okay? If you look at this picture, you are seeing different types of distributions here. We have normal distribution is here. We have skewed distributions are here. Then, if you enlarge it, you are going to see multi-modal distributions. Okay? So, what we did was to look at the parameters. We vary the parameters and use our programming language and use our laptop. Of course, we have a very high computing machine, and we're able to get this graph. Very beautiful. So this is what we have. This thing interprets that equation 10. And we decided because there's no way you develop statistical methods without talking about data. Because anytime you develop statistical methods and it's not applied to data, it's not complete. You will not see the beauty. That is why we say mathematics, statistics, and data must romance. They must come together for you to have statistical method for data analysis and interpretation. So because of that, we applied it to data sets. We collected 3 data sets. Data set 1 talks about the distribution of households that source electricity supply from Power Holding Company of Nigeria. In 2010, we have the data set 2, percentage of under 5 children sleeping under mosquito nests in each of the states in Nigeria. Then the data set 3 talks about tuberculosis immunization coverage in some states in Nigeria in 2007. These data sets were collected from Nigeria Bureau of Statistics, Abuja, and my students traveled to Abuja to get this data. Of course, Mr. Vice Chancellor, sir, you can contract me. You are in charge of electricity on campus. Okay, so we can make use of this statistical method to answer some of the questions about the electricity supply on campus. Thank you. Then we now have the histogram, just to read the picture of how the data sets are. Then you see the first one. Talk about this first one is not normal. This different normal distribution. It is skewed. It's negative skewed. Then the other one is positive skewed. Then the third one is normal. Okay, so this we are able to show the patterns of these data sets. Of course, these are explained. Then we now started to look at the beauty of this novel distribution. We started to compare this distribution with other distributions in the literature, and we found out that our distribution performs better than the rest. These are what we compared. Then, Mr. Vice Chancellor, sir, this is Statistics of Inaugural Lectures in University of Benin. I started to look at the inaugural lectures, starting from the section of this university till the last government. Okay? And I started as a statistician to look at the patterns and also let me see what inference that I should derive from. And today I'm going to download it here and you follow me. So then this table gives us the statistics of the number of inaugural lectures that we have held. Of course, there was no inaugural lecture in the time of the pioneer vice chancellor. If I ask you here, who is the pioneer vice chancellor here? Who can tell me the name? So we'll call several names, okay? But go home and find out. But there was no inaugural lectures during the time of the pioneer vice chancellor. Then inaugural lectures started in the time of Professor Tijani Yusuf, okay? And we had just 5, only 5 that time. Then Professor Adamu Bayeki, 16. Professor Grace Ali Williams, 15. Professor Andrew Onokola, 17. Then go down. Then the last is the time of Professor Lilian Salami, 101. Please try to get the handbook, the booklet, so that because some of us here, you don't even know when inaugural lecture started, and you want to give inaugural lecture. So please try to get it. So that's the distribution of inaugural lectures over the years. Okay? Don't worry. I'm going to move it now. You will see it now. So you get the book so that you can get it. Then, if you look at it, we have the first 3 vice chancellors were appointed without delivering inaugural lecture. That means they were appointed vice chancellors but not giving inaugural lectures. Then the last 1, 2, 3, 4, 5, 6, last 6, they deliver inaugural lecture before the appointments. Okay? Then, in order to visualize the patterns of data set, for you to see it now, we are going to draw a bar chart, and you're going to see it now. Look at the beautiful thing we have, and you see the trend is going up, and so shall it be. It continues to go up because you know the reason. I'm going to tell you the reason now. Okay? Then, Mr. Vice Chancellor, sir, from the charts, a statistician may be interested in the following. What explains the spread nature of inaugural lectures in the tenures of Professors Tijani Yusuf, Adamu Baiki, and Grace Ali Williams? If you add up these 3 vice chancellors, add up the number of inaugural lectures in their time, just 36. 36, very sparse, very small, relatively small, okay? Then, what's the reason? This is due to a few number of professors in the university during their tenure or inaugural lecture delivery is seen as a non-profitable academic exercise. Maybe that time we had very few professors, and also some professors, they see inaugural lecture as a non-profitable academic exercise. So there's no need to give inaugural lecture. So maybe that is the cause. Then, what inferences as a statistician can we draw from the bountiful harvest? Of course, if you check the last 2, the time of Professor University we had 81. The time of Professor Elias Taran you have 101. When you add the 2, what do you have? 181. Okay? Now, what caused it? We now say probably, because this is the probability statement. Probably there was increase in the number of professors in the university during their tenure. Yes, this is evident. Okay? Now, this is a very crucial question to all professors here. What is the probability that a professor who has not delivered his or her inaugural lecture will be appointed a vice chancellor? You see why I'm standing here to give inaugural lecture. You will see. This one is not story. This one is not story. I'm a statistician. I'm going to give you the probability so that you don't know where you are. So that if you're a professor, you are not giving inaugural lecture. Please go home and think twice. Okay. Then the probability is 0.33. 0.33 for someone as a professor. You are not giving inaugural lecture. For you to be thinking about vice chancellor. 0.33, very minimal, very small. And the other one is 0.67. Okay? 0.67. So those of us now, after today, I will belong to the class. Okay? So you see that the chances of me becoming vice chancellor is high. 0.67. So then, and the probability that a professor who has delivered his inaugural lecture will be appointed a vice chancellor is 0.67 high. The other one low. This one high. So that's why I'm starting on here because the probability is 0.67. However, the data also reveal the following. No inaugural lecture was delivered in the tenure of the pioneer vice chancellor. Most of us here, we don't know. So if it's only this one, you can take home with. You have learned something today. That's no inaugural lecture in the time of a pioneer vice chancellor. I've given you several exercises. The first one, I think if I still remember, is for you to go home and find out the first day God started creation. Whether it's Monday, whether it's Tuesday, whether it's Sunday. Then the other one is the day God rested. Some said Sunday, some said Saturday, and some said Wednesday. Find out. Okay? Then another one I'm giving you now, but I've answered it. Oh, I've not answered it. I now said go home, find out the name of the pioneer vice chancellor. Then the other one that I asked you, I've answered it because there's no inaugural lecture in the time of pioneer vice chancellor. The number of inaugural lectures in the tenure of past vice chancellors assumed an upward trend. I show you the graph, the bar chart, okay? Then the projected number of inaugural lectures in the tenure of the current vice chancellor, our current vice chancellor, we follow the trends depicted in the bar chart under normal academic section. Mr. Vice Chancellor, sir, recommendations. These are my recommendations. The first one, the statistical practice, or rather the practice of statistics in Nigeria should be regulated by the Chartered Institute of Statisticians of Nigeria to maintain standard, and I'm a fellow, and I'm a member of this institute. I'm a fellow. That's what we are trying to, put on ground. The Planning Research Statistics (PRS) department in every establishment should be headed by a statistician. Okay, statistics should be explored. Should be explored from adequate data management and planning in the university. Academic planning division in the universities should be coordinated by a professor of statistics who understands data analytics. Mr. Vice Chancellor, sir, thank you so much because you have appointed a professor of statistics, and the young man is doing very well, and we are proud of him. And I'm not trying to hire him because he is good. He's a good statistician. Thank you, sir. The relevance of the applications of statistics in all spheres of human endeavor is not in doubt. Hence, the reintroduction of statistics as a subject in our secondary school needs government attention and possible approval. Federal, states, and local governments require the production and use of statistics to serve as inputs for all-round planning, development, and monitoring of developmental activities. Conclusion, sir. Mr. Vice Chancellor, sir, This inaugural lecture has availed me the opportunity to highlight my contributions in advancing the development of statistical methods for data analytics in the areas of regression, experimental design, response software methodology, and statistical distributions. The inaugural lecture also has outlined various statistical methods that are robust and superior to existing statistical methods in the literature. It is evident that statistical methods are key to statistical analysis in the 21st century. It has been proven in today's inaugural lecture that the romance of mathematics, statistics, and data is critical to developing statistical methods for data analysis. Mr. Vice Chancellor, sir, for me to conclude this lecture with the following quote: statisticians, just like artists, can't help but get too fond of their own models. The beauty of romance. The beauty of romance. Acknowledgements, sir. Please, I have so many people to reference or to acknowledge here, but I'm going to make it snappy because of time. Please, when you get the booklet, you will see all your names there. But the first, to God be all the glory, for God has made a carpenter's son a professor. Yeah, I say it anywhere I go. I'm a carpenter's son. I'm proud to say it. But today, I've changed the narrative. I'm grateful to my amiable Vice Chancellor, Professor Bright Edova Oroge, son. Sir, you have done so well. I'm proud of you, sir. Within a very short time, about less than 8 months, you have transformed the university. In fact, sir, we are for you. And I also want to thank all the principal officers who have also, done very well by standing beside our Vice Chancellor, not behind, beside our Vice Chancellor, and you are driving capacity and development. So thank you, sir. Thank you, sir. Thank you, sir. And all the deans and directors, I thank every one of you here. Then I must also thank the First Lady of the University, my good friend, Professor Ehiwema Omoroge, because the husband, which is our Vice Chancellor, is doing very well. So she's standing beside him, and she's doing very well. Thank you. Then I also want to thank my parents, my late parents, Chief and Mrs. Ernest Mbebu, my siblings. My eldest brother is here, who is my father, is here. So I thank you so much. And my sister, that's supposed to be here, but her son is here. Thank you so much. My wonderful in-laws. I have wonderful in-laws. I have Doctor and Evangelist Mrs. I.E. Chukwujeku. They are here. Please clap for them. This couple, you see her. She's never my wife. Well. In fact, God used them. My marriage to my wife was possible because of them. Because my wife showed me red sign. But this couple came and turned the red sign to green sign. Please, clap for her, please. Okay, then I also want to thank my brother-in-law is here, Prince SMC Okole, and also I must also thank my mother-in-law, who is supposed to be here, but she's right away in the United States of America. She doesn't go with me, so I must because this is recorded, so that you listen to it. Then I also want to thank Dr. Okoli, Dr. Ada. Yes, Dr. Ada is a pharmacist in US. It's my sister-in-law. Very nice woman. Okay. Tomorrow is my birthday. In fact, tomorrow is my birthday. So please, nobody should leave here at the end. I'm prepared to serve you. So please, just stay and stay well. Okay. Then I also want to thank the past Vice Chancellors, my Dean, Professor Emmanuel Anwoyi, is right there. Dean, thank you so much. And I also want to thank the DAP, Director of New Planning, Professor Joseph Esenwai, is right there. Thank you so much. My HOD, Professor Austin, the historian is here, thank you. And all my colleagues in the departments, I thank you so much. Other HODs present, I thank you. All my colleagues in the department and faculty, I thank you. The Professor Emeriti, I thank you. I thank you, sir. I thank you, sir. I thank every one of you. And I also want to thank all Professor present. Finally, I want to thank my wife. Finally, I want to thank my wife. Okay, my wife, Mrs. Ifi Mbebu. You are my babe. Yes. Yes. You are my sister, friend, my prayer partner. I love you. I love you. Thank you for listening. I God bless you.
Professor Julian Ibezimako Mbegu. Never seen someone so vivacious, so vibrant. In fact, the way he strutted the stage reminded me of those lads who usually engaged in debates at secondary school. Well done, Prof. Well done, well done. Another round of applause. May I now respectfully invite the representative of the Vice Chancellor to recap this wonderful lecture. Mr. Vice Chancellor. Not yet.
I'm sure the students of Professor Bibu are always happy when they are in his class. I must confess, your lecture is very exciting. Permit me to recap the lecture as delivered by Professor Bibu. The inaugural lecture illustrates a novel contribution in the advancement of statistical methods for data analysis. The lecture focuses on the development of statistical methods in regression analysis, experimental designs, response surface methodology, RSM, and statistical distributions. In linear regression analysis, a robust regression estimator, double-trained estimator DTE, is proposed to handle the problem of outlier in data. The estimator appears superior to other existing estimators in literature in terms of efficiency and robustness. To handle multivariate counterpart of linear regression, a multivariate bootstrap methodology is applied for the model specification and the determination of the model's parameters. The standard errors of the parameters estimates for the multivariate bootstrap model are small compared to that of the conventional multivariate linear regression method in literature. The use of optimality criteria in experimental designs, according to the inaugural lecturer, leads to the development of some new optimal designs. These optimal designs are useful in handling feed data in the agricultural sector. The modeling phase of the response surface methodology RSM is critical to having proper analysis of RSM data. In the light of this, the adaptive average regression AVGRO model is proposed to handle the modeling phase of ROSM. The AVGRO model actually mitigates the problem of small sample and space data peculiar with ROSM. According to the inaugural lecturer, a new locally adaptive bandwidth selector is developed to enhance better performance of local linear regression model for the modeling phase of ROSM. Professor Bebu averred that lifetime data abound in engineering, health, finance, sciences, and other sectors. And according to him, the modern statistical data distributions, the earlier classical distributions for modeling such data have limitations with the data are highly skewed or heavily tailed or multimodal. To address these challenges, Professor Bebu to address these challenges, Professor Bebu argued that a novel distribution model called Weibull generalized inverse exponential log logistic distribution is proposed, and the model performance is robust compared to other existing distributions. I congratulate the inaugural lecturer once again. Thank you.
Thank you, sir. The lecturer will now step forward to be decorated by the representative of the Vice Chancellor as we invite the family members. Yes, sir. Wife, children, brothers, sisters, please join. Just immediate family members. Thank you. And so, distinguished ladies and gentlemen, while that is going on, we would like to welcome you all to this arena. We welcome the lovely wife of the lecturer, Mrs. Felicia Umbegu. Please put your hands together. We welcome all the lovely children, Dr. Favor Umbegu, Dr. Chiamaka Umbegu, geologist Chukwu Kamene Umbegu, Chiko Dinaka Umbegu, Miracle Umbegu. Please put your hands together. Family members, Comrade Felix Umbegu, the brother, Dr. Ifeanyi, and Evangelist Mrs. Juliet Chukwujeku, who are the in-laws, Mr. Prince Okoli, brother-in-law, Mr. and Mrs. George Okolie, Lady Uche Ezekwere, Pastor Gladys Okogu. Put your hands together, please. We welcome very specially, as I invite you to applaud her, the Vice Chancellor, University of Delta Agbo, Professor Dame Stella Chiemeke. Welcome. We welcome the Registrar of that university also, Richard Omagbemi Esquire. In fact, they are sons and daughters of the soil. They are uni-best. Please put your hands together for them. Some of the best that the university is sending out. Welcome. We welcome Professor Emeritus Musa Erafuna, former DVC academic, Professor Emmanuel Onibere and his lovely wife. We welcome you. Welcome the immediate past Dean of Engineering, Professor Emmanuel Ogujo. Welcome Director Academic Planning, Professor Joseph Osenihai. Welcome Professor Susan Konyeha, Professor Kester Echenim, Professor James Odia, Professor Mrs. Vivian Audu. Welcome you, Ma. Welcome Professor Solomon Lomonihu, Professor Mrs. Francisca Egbokari, we welcome you. We welcome Professor Ofiafo Eya. We welcome the clergy, Venerable Professor J.O. Oyedeji, Very Reverend Isaac Okafo, Venerable Dr. Shola Ogbebo, Reverend Canon Uche Iwozo, Reverend Canon Dr. Nantik Gozella, all All Saints Chapel, Uniben. We welcome you all specially. Yes, please applaud them. Clap, 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 clap. We welcome Professor Charles Imaren Giaye. We welcome Professor Stephen Uwamusi. We welcome Professor Azuka Alutu. We welcome Professor Lucy Eraikweme. We welcome Professor Faith Akini Bosun. We welcome Professor Esther Okobia. We welcome Professor Togo Chukwumache. We welcome Professor Charles Nkeki. We welcome Professor A.O. Oladipupo Esquire. We welcome Professor Nkolika Anieku. Welcome, my friend. We welcome Professor A.P. of Yahweh. We welcome one. We welcome all. Distinguished ladies and gentlemen, we are almost through with the 347th inaugural lecture of the University of Benin. Let's clap for ourselves, please. Thank you, thank you, thank you. We shall now take the Uniben anthem and the third stanza of the national anthem. Please rise. So on that note, I want to specially welcome the Baba of all saints, Venerable Osaze David Egbenusi. Please help me to appreciate him. Thank you. The Vice Chancellor's entourage will now leave the auditorium.